Chapter 3.6, Example 1. Electrical parts, such as resistors and capacitors, come with specified values of their operating parameters. However, due to imprecision in manufacturing, the actual values of these parameters vary somewhat from piece to piece, even though they're supposed to be the same. The best that manufacturers can do is try to guarantee that the variations will stay within a specified range, often plus or minus 1%, plus or minus 5%, or plus and minus 10%. So let's say we have a 680 ohm resistor, and the variance is plus or minus 5%. So first, we're going to turn this 5% into a decimal, which should be 0.05. And 5% of 680 is 34 ohms. That means that for every resistor that is produced at this factory, it can be plus or minus 34 ohms from its stated value, which is 680. So let's say we're evaluating resistor R. R represents resistor in question, and then we're going to do minus 680 because that is the resistance that it's supposed to have. And it's supposed to be plus and minus 34 ohm, so that means it has to be less than or equal to 34 ohms, or R minus 680 can also be greater than or equal to negative 34 ohms. But we can also rewrite this to make it a little easier to understand. So we have negative 34 ohm is less than or equal to R minus 680 is less than or equal to 34 ohm. All I did in this step was just rearrange these two and combine them together. Now, is there a simpler way to write this? Well, we are doing absolute value, so yes, there is. And the way we do that is eliminate this side of the equation and put absolute bars around this. That way, even if our answer is negative, the absolute value will take care of it and make it positive. So our final answer should be R minus 680 is less than or equal to 34 ohms.